and welcome back. So in this video, we're going to start talking about using inverse trig functions with special angles. So this is going to refer to our special angles on our unit circle and using the inverse trigonometric functions with those. So I'm going to return to this picture that I created in the last video and just talk a little bit more about it. So part of the reason why we have these specific domains is that it accounts for where sine, cosine, and tangent are both positive and negative. So what do I mean about that? So sine is positive here in quadrant 1, and it's negative in quadrant 4. So sine is the y value, so the y values are positive in quadrant 1, but they're negative in quadrant 4. So that's part of why we choose these two quadrants to look at. But the reason cosine needs to be different is because cosine is positive in quadrant 1, it's the x value, and it's negative in quadrant 2. If we were to use quadrant 4, it would still be positive since the x values are still positive over there. So that's why we have to use quadrant 2 in order to get our negative cosine, or our negative x values. Then tangent follows similarly to sine, where tangent is positive in quadrant 1 and negative in quadrant 4. We could really move this around and use some other quadrants, but we tend to stick to these. It's just the standard convention that we use and what a calculator would use if you were to use one for any of these problems. I tend to recommend that you don't use a calculator and that we're learning this conceptually and to do it by hand as much as you can, but I just want to sort of give some backing to why we do it this way. So I want to return to 3 of the examples that we looked briefly at in the previous video. So we had sine inverse of 1/2, cosine inverse of 0, and tangent inverse of 1. So now we can add to these a little bit, and our questions always said what angle gives us this value, and so I'm going to add in the quadrants here. So for sine, it's what angle in quadrants 1 or 4 gives us a value of 1/2. For cosine, it's what angle in quadrants 1 or 2 has a value of 0. And for tangent, it's quadrants 1 and 4 gives us a value of -1. Now we can use the unit circle to find the answers to find these question marks that I have here. So starting with sine, we're looking at quadrants 1 and 4, and we know that sine is the y value. I'm looking for where sine is equal to 1/2, and I see that that's in quadrant 1. That's where it's positive. So my solution here is pi over 6, or 30 degrees. That's the angle that gives me a sine value of 1/2. So if you're asked sine inverse of 1/2 and you need to simplify it, the solution is pi over 6 or 30 degrees. Let's do the same thing now for cosine inverse of 0. So cosine looks at quadrants 1 and 2. It's the x value, and we're looking for where it's 0. So I see it's 0 here at the angle pi over 2 or 90, and so this is my answer. We would say that the inverse cosine of 0 is pi over 2 or 90 degrees. Lastly, let's repeat this for tangent. So tangent looks at quadrants 1 and 4, and we want to know where is the tangent equal to -1. This is a little more difficult because tangent is our y over x, or our sine over cosine, and so we need to think a little bit about which angle gives us a tangent value of -1. So we need to look at where the ratio of y over x, or sine over cosine, would be -1. I'm noticing that it is down here if I have negative square root of 2 over 2, and I divide it by positive square root of 2 over 2. When I take the same thing and divide it by itself, I get 1, and because of the negative, I have -1, and so the solution here is going to be this angle. Now, you might be tempted to say that it's 7 pi over 4, since that's what's on the unit circle. But with the way that we chose tangent, we need it to be between negative pi over 2 and pi over 2. So we're going to need to actually use negative pi over 4 as our angle. So we would say the inverse tangent of -1 is negative pi over 4, or negative 45 degrees. So this is the one sort of odd thing about these problems, is that you really need to use that negative angle if you're in quadrant 4, rather than going all the way around the other way. So I don't usually do this in practice, like if I'm going through these questions on my own, but I want to show you that we can do this on the graphs of sine, cosine, and tangent as well. So for our first question, we were asked for the arc sine, or the inverse sine, of 1/2. So on our graph, we can look at the output of 1/2 and see which input goes with it. So it's not specific here, but I know from my previous work that it's pi over 6. And so we can start at the output of 1/2 and then look for the input that goes with it, which is pi over 6. Similarly for cosine, if we want to look at which input gives us an output of 0, I'm seeing that it's pi over 2. And here it should become clear why we need to restrict the domain and only look at this little section. There are many values where the sine is equal to 1/2 or where the cosine is equal to 0, but we need to have only one answer to give for the inverse function. Then we can repeat this for tangent. So you'll see where is the tangent value -1, that's at the angle negative pi over 4. And hopefully seeing this graph really reinforces why we have to use that negative angle. So we're just going a little bit to the left on our inputs, and that's the angle negative pi over 4. Lastly, we can also do these problems with reference triangles instead of the unit circle or the graph. So for the inverse sine function, I know that sine is opposite over hypotenuse, and I'm looking at a positive value. So I can label the sides as 1 and 2, opposite over hypotenuse. And I know that this goes with the angle pi over 6 if I look back to my reference triangles. So this is one of my common reference triangles for my special angles, and so I can sort of identify that and know that it goes with it. We're going to talk more about how to do this later, don't worry, I'm just giving you sort of the basics here. The second problem though isn't going to be as easy with the triangle because we have an output of 0, so that would be a side length for our triangle of 0, and we can't have no side length, so we don't have a triangle for this one. So tangent is a little more tricky. If I was to look at my reference triangles, after looking a little bit, you might see that the opposite over the adjacent would need to be square root of 2 over square root of 2 to get a value of 1 for my tangent, and one of those sides is going to need to be negative in order to make it a negative one. So this is going to correspond with the negative pi over 4 triangle. Doing this takes a little practice, and so we're going to talk more about it later, but I just wanted to show it to you now to start making those connections. So anytime you're asked to find an inverse trig function, at least with the special angles, you can imagine doing it either on the unit circle, with a reference triangle, or with the graph. So those are some basic examples of using inverse trig functions with special angles. I'm going to go into a lot more depth in my next example video, so check that out to get more into this and to get some more practice. Thanks so much for watching, and I will talk to you in the next one.